If you're a business owner or senior manager, you probably had more than enough about all the wonderful opportunities awaiting you in the era of digitalization.
Whether it is big data, cloud, data science, or whatever buzzword is currently trendy.
If you would like to hear someone dissecting these claims and showing you what it actually takes to improve business processes, you're in the right place.
This is Between Data and Risk, where we discuss real-life examples of what works and what doesn't in the world of business operations. Hello, I'm Artur Cognition Shared Solution Chief Risk and Strategy Officer, and with me is my co-host, your friendly neighborhood data guy, Dr. Marian.
Hello, everyone.
Welcome to the 10th episode of Between Data and Risk, and today we decided to talk about design thinking as it's not really a methodology of designing, more like a mindset. And you know, it has gained popularity recently quite a lot. There are whole websites, courses. It's been introduced in books. Even in my last job as CRO in HSBC, I was given a course on an internal course on design thinking, and I was recommended to read a book on design thinking. So it is making quite a lot of waves in the world. Great. So what is it? Design thinking. I thought you'd never ask. So it is a mindset where you put human first. You put the user first. The human centricity of it is something that you should start with, and then there's a lot of emphasis on like an explorer mindset, on collaboration. A very good system, kind of for design thinking, has been promoted by a German University of Potsdam. And in that kind of system, they have separated several phases of design thinking. So the first phase, which really kind of emphasizes the basics of it, is to understand, right? Understand the problem. It is something that should be very, very common sense. But again, we always say common sense is not that common. It should almost be a tagline for the podcast. So you should understand what is the problem, where actually the problem lies, who has the problem. Here is the kind of emphasis on human centricity, and how it affects the people who have the problem.
If I may drop in, it's like, seems like whatever problem we tackle, be it data, be it risk, be it, I don't know, enterprise architecture, whatever we talk about in our episodes, we start with the problem understanding. It looks like it's a basis of, and it seems almost like it's required to actually solve a problem. And I'm really wondering why people tend to try to save money and time on skipping this step. Maybe you can tell me. Sorry to stop it.
No, it's a very good question.
Because, when data science was introduced, all right, it was about taking a scientific approach. It was about scientific method, which is based around understanding what is really in the data, what data tells you. We had an episode about listening to data tells you, and it was immediately hijacked by machine learning experts who just dropped the data into more and more advanced tools and AIs and artificial stupids just to get some result fast. Is it really possible to find time to understand something in the company?
Well, it's necessary, right? It's one of those things that tends to be overlooked, and partly it's because people are so pressured for results immediately that they just jump to conclusions. Partly because people tend to, jump back onto the solutions that have worked previously. So, if, like the old saying, if you have a hammer, everything looks like a nail. So there seems to be a lack of lack of time or lack of understanding of the understanding phase, right? The necessity of it. That's why pretty much every mindset, every methodology that comes out and that is making waves in the business world, in the academic world, it starts with you have to remember to understand what you're actually trying to solve.
Okay, so
here the emphasis is slightly different because you're meant to understand the problem from the human side. So a big point is made to understand how it affects the people that have the problem.
It doesn't matter. I'm talking about the general problem because, seems like everywhere we turn, it seems like understanding the problem, taking time to understand the problem would help in identifying the correct solution. And now, from the perspective of senior manager, you've been, let's say, C-level executive in a tier 1 bank. What can you do as a C-level executive to incite this need of understanding? If I have a problem, I should probably understand it before I will try to patch it.
I always try to do it by asking the right questions because I think the worst kind of management is the kind of management when you say, I'm not interested in it, just solve it. So this kind of almost immediately sends the message that you don't care, right? Whereas if you don't really need to receive the answers, but you need to ask the right questions. Do you understand the problem? Do you know who's affected? If the questions you ask start with "Do you know?", you not necessarily kind of start micromanaging because you're not saying "Tell me what is the problem? Tell me the details," but you're asking "Do you know?" You're asking the team whether they have actually taken the time to investigate it, to find the knowledge for themselves. If they tell you, yes, we know, then obviously you have to have some trust in them that they're not trying to pull wool over your eyes. But that's a trust is a completely different issue. We'll come to that probably sometime. Ask the right questions, and then you'll drive the right behavior by asking the questions that should be answered.
Okay, I like it. I like this approach. I like asking questions. I hate answering them in 6 different forms, in 6 different formats, on 6 different PowerPoints, plus 2 Excels. That's something. Yeah,
I remember the story that you were telling where you put the information on a PowerPoint presentation and you were trying to talk about it, but instead you were forced to read it because people were just too lazy to read it for themselves. But this was exactly the kind of behavior which I'm talking about, where people were asking you to give them the information, even though you were treating them as high-level executives, but they were trying to micromanage. They were trying to get nitty-gritty, but actually by being lazy, but asking you to spoon feed them the information rather than trusting you that you have the information. Yeah?
It was question about the dates presented on the Gantt chart. It's not spoon feeding, but let's not go into my frustrations from my previous work experiences. All right, so we need to take time to understand the problem, understand the people who are affected, and it works to my understanding, on every level. You can do it being a CEO,
Absolutely.
You can do it being an intern, you can do it being I don't know.
So as a CEO or any senior executive, as I say, it's best to drive the behavior. You don't necessarily need to understand the problem yourself, but you need to drive the behavior where you're sending the message to your teams, to your organization, that they should understand the problem. They should take the time, because doing something without understanding is obviously a best recipe for disaster. And then the next phase is alternatively called observe or empathize. I like empathize because it goes back to this human centricity. Understanding is intellectual, whereas empathy is more emotional. And this phase is more about trying to break down the problem such that you resolve your assumptions, you research the specifics of the actual situations where the problem occurs. You challenge your own preconceptions about the problem. And what better way to kind of do this than by observing, by actually going to the client or to your teams and observing what happens, right? Obviously, I'm not talking about the CEO going and observing the shop floor, but if you have a team that's or one of your managers dedicated to solving a problem, ask them to actually go down and observe what's happening, and that this way they will get much more information than just by reading reports or listening to stories. Listening to story is already filtering the information through someone's brain, and you may be filtering out very pertinent details. Observing, make sure that you receive a lot of nonverbal information that is crucial. Right?
We spoke in the last episode about something similar, if I remember correctly. Filtering of information. You want to get sometimes you want to get as close to the source as possible, because what you get is very often filtered by somebody else's thought processes, by somebody else's, I don't know, expectations or anything like that.
Yes, and it's the same. It's the same process, because with Tushar in the last episode we spoke about how reporting, as it goes higher within the organization, it gets filtered and people put kind of their spin on it to make them look better. Here, you may get the same thing. Someone may be telling you about the problem, but they may be leaving out pieces of information that they're not comfortable about. Or they're unsure of. So by actually observing the problem, so to speak, in the wild, you have a much better chance of catching all those details, right?
I would guess so.
Then the next phase is synthesize, and synthesis is about putting the information together and pulling out the most crucial bits. And this can be, on whiteboards, on sticky notes, or, it's really medium independent. But it's if you have a group of people, because design thinking is about collaboration, you have to share the information, infer the meaning of the actual data that you've gathered, identify the key information, and then select the ones that are actually most pertinent to the solution, work them through, kind of rephrase them, put them in a language that everyone can understand, and start building the understanding as a whole. Because when you're observing, when you're understanding intellectually, you're probably going to start with pieces. Now, in the synthesis, as the name suggests, you're building a whole and grouping the problem into bigger and bigger bits until you've covered the whole problem space.
This is something very interesting with this common language. In data mesh, we use the phrase ubiquitous language. Which is which means it's one of the methods of designing the boundaries for business domains. The people who speak the same language, they probably deal with the same problem, and they should be grouped together as a unit. And it's one of the ways of ensuring that the data that you have in one place is consistently and thoroughly described, is to ensure that all the people who deal with this data speak the same language. The second, not so technical approach, it was recently described in Design Better podcast. Dr. Sian Proctor spoke about building common languages, where you have a group of people who are of diverse backgrounds, diverse experiences, how to ensure that the communication is communication sent is a communication received. It is critical to ensure the success of any group activity. And I think it's also very often overlooked is taking time to ensure that everybody is seeing the same and understanding the same. It's like explaining that on a Gantt chart on the top you have dates, and the dates that are there are the dates when the activity is described below start. So it's about ensuring that everybody's understanding of some concepts and words, especially in today's world where we have a lot of jargon in the companies, we have a lot of business domain specific vocabulary. Building this common language is important, but also I think it is important to unify the language of priorities. We spoke about value statements. We spoke about ensuring that the example comes from the top, but this expectations is also, in my personal opinion, an element of language. If I say that something is critical, it doesn't mean that if I won't get it by Friday evening, I will be a bit uneasy. It means that a bigger process will fail.
Yeah, and I really like this Design Better podcast. Dr. Sean Proctor really hit the nail on the head when she spoke about the common languages, because we see this with our teams. We send a team to the client, they do the interviews, they bring their notes, interviewing the chief execs or senior management, and then you really have to sit down and bring those notes to a common level, because they diverge in their phrasing, they diverge in their vocabulary sometimes, and you have to kind of connect the dots and equate certain thoughts, certain phrases to try to build a coherent picture. Otherwise, you will see very few overlaps very often. So this is something that we see in our daily practice, pretty much.
I'm one of the guys who actually came up with an idea of sending data guy, process guy, and the risk guy into our clients. I couldn't agree more. I would have to undermine my own effort to do so. It's if you are an exec, and if you want to get a good picture and good understanding and good both analysis and synthesis of the problem, it's good to listen to more than one trusty right hand person. It's good to listen to multiple people. They will and ensure that in the end, after they collected their thoughts, they have an ability to communicate.
It actually it sounded very funny. Sorry, I have to kind of put a lighter note on this, because I would kick myself if I lost this opportunity. It sounds like a beginning of a joke. A process guy and a data guy and a risk guy go to a client. So here's a kind of a question for our listeners. If you can send us your best joke, starting with a process guy, a data guy, and a risk guy go to a client. We'll think of some award for this contest, but it really is a great opportunity, I think, for some humor. So Now, on a serious note, let's go to the next phase. So we've got understanding, we've got observing, we've got the synthesis. So now we think we have a grasp on the problem. Now the time is to ideate, right? Actually create some ideas about what we want to do. And here there is a whole plethora of methods. There is, as I said in the beginning, design thinking is not really a standard operating procedure where you have to follow the specific steps. It's more a framework. We love frameworks, right? And so here, in ideation, you should be deciding on specific approaches that you want to explore. Not the specific approach. This is the crucial difference. It's not deciding on a specific approach you want to take. It's deciding on approaches you want to explore. Because the chances that you will hit the solution in step one are slim to none, right? So think outside the box, speculate, kind of a bit whimsically. Some methods that are suggested is ask yourself, what would your favorite superhero do? Or, brainstorming methods like hot potato, the 6-3-5 method, which was actually news to me. Have you ever heard of the 6-3-5 method?
6-3-5? No, I can't say I
You
did.
take 6 people and each one writes down 3 ideas. Then for 5 minutes, those ideas are kind of discussed and mulled over. And then they swap papers and it begins kind of anew. And it's a method to collaboratively exchange ideas, criticize them in a very kind of
organized
chaos almost. So, it all sounds very kind of faddy and
I'm an old and grumpy control freak. So,
this method is supposed to bring you out of this old grumpy controlled freakishness, and try something new and actually collaborate with people.
Can you convince me that discussing, we have 6 people, 3 ideas each, 18 ideas for 5 minutes. Out of these 18 ideas, probably 15 are being added just, to fill out the space. How would you convince me about the value of throwing so much noise into meaningful communication?
It is the basic premise of brainstorming. Come up with wild ideas, and if you're in a mental valley, it's only small explosions put randomly that can kick propel you out of that valley and into new heights of exploration. So
I understand that in risk finance you use a lot of Monte Carlo methods, and you randomly go from some starting point into end directions and hope that you will get somewhere, let's say, in a place where it makes sense. But can you tell me, why is it so computationally expensive to calculate stuff with Monte Carlo?
It's because you have to explore the probability space,
and you need to run this simulation millions and millions of times, hoping that the random. I'm personally more into genetic algorithms where you get into. However, in genetic algorithms, the outcome. On the other hand, if you have a problem, you also would want to have some sort of desired target
like
state.
Monte Carlo methods. The whole point is to explore the probability space, and this allows you to solve problems which are not algebraically tractable. So it is actually a great analogy, because throwing darts at a board of wild ideas, this hypothetical board that contains all the ideas in the world, you're just throwing darts and seeing what sticks. And it doesn't mean you should go in all those directions. Obviously, you should then apply some sort of analysis to see if those ideas actually make sense. But as whimsical as it sounds, asking yourself what would your favorite superhero do is a good mental exercise, just to
blast
ask
everything
yourself.
to pieces. For sure.
It's a way of asking yourself in a different way. Is there something I haven't thought about? And if you ask yourself, is there something I haven't thought about, you're immediately putting the kind of the blame on yourself, almost implicitly saying, is there something that I've done wrong? Whereas if you ask yourself, what would your favorite superhero do? You do the same thing, but allowing yourself to fantasize. And I'm actually a big fan, as long as it's done for a purpose and not just as a, just for fun.
I understand. My worry is about the efficiency of the time spent on such exercises, and how often does it really bring a new solution?
You'd be surprised. You'd be surprised. This is exactly what I'm talking about. Allow your teams the time to explore that probability space, because it's if you constrain the time too much. I'm not talking about allowing them to sit around for days and think, okay, what would this superhero do? How about this superhero? How about this superhero? Because then it becomes just an exercise in futility. But having some kind of mental jolt once in a while, just it allows you to think really outside the box, and it's not just a phrase.
But it reminds me, we had a discussion with Dr. Swain recently, and he was telling us how he, let's say, kickstarted some activities in his college that he's a president of, and he said that the problem was that they had a very simple task. They were supposed to replace the signage on the campus so it's more meaningful, and they were working on it for 3 years, and they were having meetings, and they were trying to find a consensus. They had brainstorms. They were trying to come, to collectively, brainstorm some great idea. And in the end, he said, "Don't let the perfect stop you from doing good enough." And they ended up with the pretty simple and but effective sign for the first building, and they took it from there. He hoped for something more creative, but what we got was fully functional. Does function need a superhero?
Here we come to the next phase of design thinking, and you've just hit the nail on the head. The next phase is prototype. And this is what was missing, I think, from Dr. Swain's team, from their process. The prototyping was missing, because the design thinking says whenever you have an idea that seems very fairly viable, has some kind of probability of success, just go and prototype. If they did that, if they said, okay, we've got some kind of design for a sign, let's stick it in and see what happens. And this is exactly what Dr. Swain said, right? They came to him after he kind of prompted them to do something. They came to him with a design, and he just said, stick it in and see what happens. And they stuck the sign in front of the building, and it worked. Maybe it requires some improvement later on, but it did the initial job. So prototyping is the key here. Learn more by trying and then seeing the results. Trying to achieve perfect in the first iteration is going to lead you to analysis paralysis, and it's learn by doing. Get more information and identify your constraints. Obviously, the big constraints you identify up front, by identify the smaller constraints by actually trying to do it and seeing where what stops you. Right? There's a kind of old saying that people who say it can't be done shouldn't interrupt people who are actually doing it. So I think it applies here. People who want to achieve the perfect should not be stopping people who are trying to do something and move in the right directions incrementally, stepwise, but are actually trying to move in the right direction. And the final phrase is test. And this is linked with prototype. Put a prototype together, put it in front of the user, and ask them what they think. Within certain constraints, which are, again, should be common sense. Safety, cost, regulation. But if you meet those common sense constraints, put it in front of the user, see what they do with it. If they break it, fine, you learn something. If they don't like it, you learn something. If they like certain bits of it, you know which direction to go in. And this can be applied. I saw a kind of great podcast by Dawan Stanford, Design Thinking 101. And in his podcast, he actually gives great examples of application. If you're interested in design thinking kind of basics, I would start with episode 32, which is the kind of introduction to design thinking. But subsequent episodes give very, very good examples of how design thinking is applied in practice and where it allowed the designers to jolt themselves out of this mundane thinking or out of perfectionism and just try something and see what sticks.
I'm trying to be a bit practical here. So let's say I can imagine this is pretty useful when you are designing, I don't know, new baby shoes or new mousetrap that we spoke about with Dr. Swain. But let's some of our listeners are senior executives. They are responsible for big chunks of business operations. It's easy to say, okay, prototype and test. Okay, I can make a prototype of a mousetrap, put it next to the mouse and see if it will, bite or not. But, how do you transfer this happy running around waving innovation flag into decisions which affect thousands of people, billions of dollars? It sounds cool, but does it really translate? And does it really translate into the world where decisions are serious with far-reaching consequences, and where each change can lead? Like, I'm still waiting for a formalized way of saying, think about the consequences of what you will do. Because we had this understand the problem. I like it. We do it in our job. We take 3 people or 4, send it to the client, or we go ourselves and we are asking people, okay, how does it work? We map the processes. Then when we try to change the process, we check, okay, how it will affect the downstream of the element that we want to change. We have a synergistic prioritization matrix, which is built. We spoke about it also with Dr. Tushar, which are designed to ensure that the consequences and the risks associated with the change are properly analyzed. And now here we have a completely different approach. So, let's change something. Let's create a prototype and happily see how it will work. Let's observe how the world. Oh, there's a big red button. Let's press it.
I know you're trying to kind of be, you're trying to explore the problem in a semi-humorous way, but it's not about it's not about a big red button. I'll give you a practical example, right? In one of the institutions I worked for, we were trying to design a new credit approval system. Okay. And it is a decision which, a change which could affect millions of dollars and affect a lot of people. But the way you don't do it is think of something and implement it. The keyword here is prototype. And one of the kind of one of the conditions that comes with prototyping is that you don't switch your whole your whole train to the new track and see if it crashes, is you switch a small group of people. So you select a small group of people with low risk and apply the proof of concept to that group of people in a controlled fashion. So you inform them, you're now going to go through our improved process. We're going to try it with you. If they don't agree, you give them the option of trying the old process. But if they agree, you go through the new process. You control it, right?
Okay, so you have your mice, you have your mousetrap. They are running happily around, or not. Depends on the effectiveness of the mousetrap, of course. I will give you another example. You have a chemical industry. I had the pleasure of working with a couple of them. And there are startups that come up with this brilliant idea. Yes, this new way of doing a chemical process is 5 times more effective. Like they run to BASF or some other gigantic company, say, yes, we can make your chemical processes 5% more effective. And they usually hear, no, sorry, stopping our processes for the time required to implement the required hardware change would cost us so much that we won't make this 5%. Usually it's 0.5%, 0.005%. It won't cover the costs that we will incur by stopping our process. So when you have when you have a running train, it's really hard sometimes to detach one wagon and push it to a different track on the fly. It's the train is running.
Hopefully you mean detach one car, not one vegan. You don't want to detach vegans from a train.
unless it's a meat transporting.
But to answer your question, I think where those startups fail is not on the prototyping. They failed much earlier on the understanding, because they failed to understand that their client or their problem owner already has a big constraint. They have a chemical plant that cannot be stopped unless you can provide a replacement value for probably millions or tens of millions of dollars. So asking a company to invest tens of millions of dollars in order to get a return of several $100,000 is obviously nonsense. And this is something that they failed on the understanding part. So it has nothing to do with prototyping. The prototyping part would be, I want to improve a chemical process. And in order to understand what the problem is, I have to understand how much I need to improve in order for the change to be viable. That's a key point of understanding. Then I prototype. And if a prototype says I have to stop this massive train for say a month to do the necessary changes, but I will only provide a small value, you throw that solution away because it doesn't meet the requirement.
It's a pretty interesting thought that you presented, is that element of understanding is analysis of the required efficiency increase or whatever.
Common sense.
But should be most of the processes, like you think, okay, I think we need to improve it, and the clients are not happy with it, or I don't know, this building the proper matrix of constraints is something which is, I think, it's necessary. It's actually pretty interesting thought.
There are two concepts within design thinking which overlap and actually not overlap, but intermesh, and are I think very important for understanding this. There's the problem space and the solution space. And you have to find the kind of the common ground between the problem space and the solution space within the constraints that are defined. And, if you have different industries, those industries will have different constraints. Obviously, in healthcare, you will think about the good of the patient, about their privacy, about their feelings, their kind of their mental state, the
well-being,
well-being in general. If you're thinking about chemical or oil industries, you will think about environment constraints, regulatory constraints. Those are the kind of they define the boundaries of the solution space. You cannot find a solution that will breach those constraints. Problem space defines you the constraints of the problem. If you cannot go you cannot find a solution that doesn't address the problem, because obviously it would be nonsense. So
you need to find a very respectful superhero that will not violate these constraints.
Exactly. So only if you meet the both the constraints of your problem and the constraints of your solution, then you will have a viable way forward. And prototyping is you say it's random, but it's not really random, because even in Monte Carlo methods, you don't just run a random number generator. You run a random number generator and then put those random numbers through certain operations to constrain them to the probability space. So the same way you brainstorm, you come up with wild ideas, but then you weed out the ones that violate your constraints. But hopefully they will unlock your thinking to come closer, because you will understand. You don't just discard a solution if it violates a constraint. You ask yourself, why does it violate the constraint? Can it bring you closer to a solution by solving that constraint problem as a smaller problem and bring you closer to the boundary? So
almost like gradient descent.
Yes, it's a gradient descent, but in design thinking, it's called diverge and converge. So the process is that you should diverge in your thinking to wild ideas, and then weed out the ones that are not just by discarding them, but think about where they are, why the certain solutions, certain pathways are outside the boundaries, and converge back into your problem space. Once you have, it's almost like genetic algorithms. You said you like genetic algorithms, right?
Of course.
First, you breed your solutions, and then you weed out the ones that do not survive, and then again you breed the solutions and weed out the ones that don't survive.
You try not to breed them too widely. You don't need to generate hundreds and millions of them. No, my problem is as usual. It's common sense is not that common. The danger that I see is that the discussions the solutions being discussed are usually of the loudest and most obnoxious people. This is my biggest, I think, problem with brainstorming, is that this storm very often quickly becomes storm of something completely different than brains.
Yes, but this is why I think design thinking should be taught to people, from the youngest ages, because and it teaches collaboration, it teaches respect, it teaches a certain kind of thinking. In fact, while researching for this podcast, I found Dan Ryder, educator, improviser, design thinker, as he describes himself, and he wrote a book, Intention: Critical Creativity in the Classroom. He's in fact a big promoter of teaching design thinking in primary education. So he's definitely someone to kind of maybe we want to invite to a future podcast. In fact, Dan Ryder, if you're thinking, consider yourself invited. We will be contacting you, one note, we'll have to bring diet soda, because on his website he describes that he drinks diet soda instead of coffee. So his dentist frowned upon this, but obviously we want to make our guests comfortable. So And it links very nicely to the next episode, because we will be talking to someone who is very much involved in education, Dr. Susan Taffer. We will be talking about the education aspects of processes. So I think it links very nicely to that topic.
Okay, are there any more steps to design thinking? Because we spoke, but we need to understand the problem, including the constraints of the both problem and solution spaces. In example, budgetary. We spoke about observing if our understanding is correct, which I would personally probably try to interlink these two, doing them step by step. Is like, okay, so now that I understand it, now I will observe it. If I will not update my understanding, this observation is worthless, but well, hey ho. We are big fans of feedback.
That's why you should update your understanding, right? That's the whole point.
That's not obvious from linear structure of these steps. Then you should ideate, and then you should prototype. So we have 4 steps. Is it all there is to design thinking, or is there anything else?
The next one was test, right? So test your prototyping and see what fits. And you're talking about the circular nature of the linear nature of the process. In fact, you shouldn't treat it linearly, because there is a certain iterativeness, and it requires exactly the mindset that for some reason you're not displaying today, and that is it requires openness to possibilities and embracing uncertainty. It requires a certain kind of approach, learning through your experiments, learning through what you've what you do, rather than just sitting around and trying to design the perfect mousetrap. Just go out there and test 10 mousetraps and see which ones actually catch your mouse. It requires an exploratory spirit almost.
And budget. Because the question is like, if you, I understand, I believe it's pretty much connected to a continuous CI/CD methodology.
Continuous integration, continuous deployment. Yeah, but that's an IT term, right?
Yeah, but still, it works well in software world where code is cheap, relatively. I just wonder how much applicable it might work when you are, again, designing a product which might be pretty cheap to prototype. I'm just thinking, what if you have really tight time constraints? Does it apply then as well? Because like all this brainstorming and discussing useless ideas takes time. Testing it and then coming back to the drawing board takes time. As I said, for me, it seems a little like searching for a perfect solution instead of coming up with one which will be well thought through and well defined, with well thought. Maybe 1, 2, 3. I'm not saying
exactly
the first
the opposite. It's exactly the opposite, because when you prototype, if you find something that works, you can expand it. I said test it on 1 user, test it on 10 users. You don't have to if you have 1 million users, you don't have to test it on all of them. Test it on 1 user, 10 users.
I'm talking about time.
It's quicker to test on 1 user than test on 1 million. And if it works for 1 user, then test it on 10, test it on 100. And if it moves you forward, then deploy it to 1 million and look for a next iteration.
Now you spend 3 iterations of testing to get to 100 people. And
yes, but I've moved forward. I've moved forward with my idea rather than spending the same amount of time.
Optimistically, assuming that your solution worked for the first one.
The Japanese have an idea of Kaizen, continuous improvement. It's very much connected with that, and it's really in practice. if done correctly, i.e. people actually do it with the mindset that they're trying to explore and deliver as a solution and improvement, rather than, okay, we've been giving free rein so we can just sit about, have coffee, play some ping pong. It's not about this kind of wasting time. It's about actually purposeful work, but with the mandate that you're allowed to ask questions. You're allowed. There are no stupid questions. There are only questions which bring you closer to understanding of the solution,
or the ones that are just voice to fill the space. If what you said was true, I'm worried. Maybe that's why I'm so negative about it, because it sounds like it gets rid of consultants. Take a random group of people into the room, let them brainstorm and prototype, and they will come up with solutions which otherwise require years of experience and learning. I don't really feel it deep in my gut that all the answers are there locked in our brains, and all we need to do is to shake it, to spill it out, to be honest.
Exactly the opposite. The answer shouldn't be in your brain. The answer should be out there in the wild, in the practice, in the experience of your users. What the whole point of going out and understanding, observing, empathizing is not to use your experience to solve the problem. It's to use the experience of your users, the knowledge of your users, their practical examples to solve the problem. And this is, as consultants, this is exactly what we do. There are consultants which go to the client and say, okay, I've got this method which I used with last client, and I will use it with you and it will work. We've got a framework, but we always emphasize it that our framework is a framework which we use to approach a problem. We're not going to apply the same solution to the next client. And this is exactly what we do. We go to a client, we listen to them, we find out where their problems are, we empathize, and we prototype. So design thinking shouldn't really be anything new to you, because this is what you actually are doing. Except it's described as in this kind of lofty way, because this is the way people these days like to have things described, and they like the whole verbiage around it. But in practice, this is exactly what we do. The exploratory spirit that we're talking about is exactly the willingness to learn that we share, and that we have made actually a value in our own company. So I'm slightly baffled by your kind of negative approach to it.
It's my negative approach is pretty easy to explain. It's as you said, it's all in feedback loops, and for me personally, it's about thinking about consequences, and it's not maybe emphasized enough. It emphasizes with prototyping and testing and like constant moving forward. In my work, like to think before I will do something. I like to think about what will be the consequences of it, and this is hidden deep in understand the problem first, observe second. Understanding comes from observation. So disconnecting the cause and effect here. Maybe it's a verbiage. Maybe it's just I do not really appreciate the way it's being, let's say, structured.
This is exactly what we do. If we go to a client, we first read up on their business. We read up on their operations.
We never say that we finished understanding phase. This is what I'm talking about. But you have a phase of understanding. No, it's an element of understanding phase. All the interviews that we perform are leading us to the point where we can understand. Without observing, we cannot understand. Disconnecting these two is dangerous.
No, but here the understanding is emphasizing the intellectual understanding, and observing is emphasizing the practical understanding. You cannot go to a client in a new industry and say, okay, now you go to a semiconductor manufacturer
Industry,
and you say, okay, now tell me what a semiconductor is, because I didn't read anything. I know nothing about your business. Let's start with the basic. What is a semiconductor? You would look stupid, right? What you do is first you read, you prepare yourself intellectually, and then you go to a client, and with that intellectual background, you observe.
In my opinion, the verbiage is dangerous. As you said, common sense is not that common. What you say is implicit, not explicit. And me, as a semi-amateur coder in Python, I believe implicit is better than explicit. What I am opposing is all these underlying assumptions which are not brought to light and which are making this method deceptively easy to use, and without all these asterisks that you put and footnotes, it may be really misleading. That's my worry. It's not the design thinking itself. It's the mix up of easy to understand words with a deeper meaning, which is for some reason like hidden. Because
it's interesting that you talk about thinking about consequences and thinking about constraints, and here myself the risk guy is I'm advocating for this method because I understand kind of you're right implicitly that without constraints it would be mayhem. So maybe we do need Dan Ryder or Dawan Stanford to come in and explain it to us better, because we seem to have swapped roles in this discussion. If to anyone who's listening, if you have any questions or any comments on this discussion, obviously let us know, because we seem to have reach a certain kind of impasse. But I can assure any clients who are listening that Marian is usually not that negative about new ideas. He's playing a role here.
I am just thinking about the consequences.
Yes, you are. But I think this is all we have time for today. So again, let's hope it's of some use to someone. Thank you for listening. For a good discussion on design thinking from someone who actually knows something about it, we recommend listening to Dawan Stanford's podcast, the aptly named Design Thinking 101, on Apple Podcasts, especially episode 32, the introduction to design thinking.
For a slightly different perspective, looking at design thinking from a method, strategy, and mindset point of view, check out Dan Ryder's book, Intention: Critical Creativity in the Classroom. As usual, all links to the references will be available in the notes to this episode.
Also, don't miss the next one, where we'll be talking to Dr. Susan Taffer, entrepreneur and educator, about the difference between education and knowledge transfer.
Subscribe on your favorite podcast platform or visit bda.show to find out more about the future episodes and guests. You can also check out cognition.llc for more information on Cognition Shared Solutions, our services, and other events hosted by us.
For now, it's thank you from myself, Artur Guja, and my co-host, your friendly neighborhood data guy, Dr. Marian.
Thank you. Goodbye.